we have two problems, right? One was the wastage of space. We had sorted it now. The another problem was that in the case of the array, there's a fixed size, right? So if we have to fix that issue, one of the approach can be just like how we did in the case of the stack. We keep a dynamic size array, right? We keep on increasing doubling the size of the array once it reaches its full capacity. That is one approach. What was the another approach that we did in the case of the stack, if you remember? What is the another data structure that we used?
Linked list.
Linked list, right? So if we use linked list, again in the linked list, since the size can be increased dynamically, right? The size can be increased dynamically. We can use linked list as a data structure again to implement the queue as well, right? So let's try to see that. Okay, so we are trying to now again I have a queue. So for the first time, the queue I have trying to add an element into the queue. What should the first thing that we should do here? What should we do? We can create a linked list, a node of size 5, and this is pointing to the null, right? And here head is equals to tail equals to 5, right? This is the first thing that we do. If I do q.enqueue1, what should I do now? Should I make one as a new head, or should I make one as a new tail? What should you do? What will you do?
Should we assign head to one? Because
Now
anyway,
it all depends on how you want to do. So normally in a linked list, from the head we move towards the tail, right? From the head we move toward the tail traversal. So you can decide on whether you want to keep front as your head, or if you want to keep the tail as your front, right? So for example, if you suppose you want to keep head as your front, in that case you should go add one in the head. But if you want to have a definition that no, I want to keep my tail as my front, so I can go add one at the tail. So for example, we have decided that my front will be head, and suppose my rear will be tail. Okay. Suppose this is the case. So the front is the head. So in that case, I'll go and create one as the head and add like this. But I'll keep a track of who's my head and what is my tail. So this is my front, which is a head, and this is my the rear. Again, when I go and add 7 into it, right, again the 7 will get added here, 7, then 1, then 5, and this will be my front, and this will be my rear, right, and this will be pointing to the. Now when I do a DQ, so when I do a DQ, we always go and DQ from the rear, since I already know what my rear is. Now there is a problem when I keep the front as the head and the rear as the tail. Can you guys tell me what is the problem? The real problem is, right, so suppose now I have to DQ thing, right? So when I have to DQ thing, I have to basically return 5, right? So basically this element has to be reduced, and my new tail should be this should be my new tail. But to make this new tail, I cannot go back because it is a single linked list, right? In a single linked list, you can only move in one direction, from the left to right. So in a constant time, you cannot go to the previous step. For that, to coming to the previous step, you have to start coming from this direction, right? So to start coming from this direction, keep on traversing, coming to the second last position, that will take linear time. That will not be a constant time, right? So whenever you are trying to DQ element, you have to again reset the rear pointer. But resetting the rear pointer to the previous element is not possible efficiently in the case of a single linked list. You will have to, traverse the whole thing again from the head to come to the second last position, and this will not be done in a constant time. So in this case, the DQ operation will start happening in a linear time and not the constant time. So
Yes, sir.
how to sort it out? Can you think of any solution how to sort it out? What we can do here is that we can just change this. So instead of keeping the front as a head, we keep the front as the tail and the rear as head. So with this, what happens? Let's try to see it. So initially, say 5 was added, so we created a node of 5, and this was pointing to null, and this was my head also, and this was my tail also. Basically, this was my front also, and this was my rear also. Okay. Then I go and add 1 to it. So the 5 remained the same, and then I added 1 to it. Okay, so this may became front, and this is my rear. Now again I added 7, 5, 1, and then 7. Now 7 is now my new front, and this is my new rear. Right. Now when I have to do a DQ, I can simply go ahead. So DQ will return me 5. So I'll just go and take it out from here, and I just move head is got to head dot get next. So I'm just left with this one 7. So this is my front, and this is my new rear. The issue was happening only in the case of when I'm trying to DQ, when I'm trying to delete a node. So when I'm trying to delete a node, I can always move from the left to right. That was not a problem. The moving from right to left was a problem. So if we just change and we keep the rear as the head and the front as a tail, this problem gets sorted out. Cool. So this implementation I'm not going to write. So this will be an assignment for you. So implement queue using linked list. And even the previous implementation that I wrote, please try to add the implementation of that in your language of your choice. Okay, so please implement queue using array, as well as please implement queue using linked list. Please use these two data structures to implement queue.